All right. Good afternoon, everyone. We're going to go ahead and look into section 3 now of Unit 4. We're talking about periodic trends or periodic properties and patterns that we can look at using our periodic table. We're going to take a little bit of time, sort of look at these things a little bit deeper and see how we can utilize the information to find out even more about the elements that we're dealing with. Now, again, if you have questions, please write them down. Please don't sit there and say, "Oh, Mr. Baldwin, I don't understand what's going on. I just didn't. I just stopped." Write down the information and then put like a little question mark next to one part that doesn't make any sense, and then we'll see if we can't explain that when we get into class. Now, the first trend that we're going to look at is one of the simpler ones, which is atomic mass. Now, this is the way that Mendeleev originally actually organized the periodic table. We find this on our periodic table. It's that number with the decimal at the bottom of the box. Now, this is going to be based on the mass of the protons and neutrons in the atom, which gives us a little bit of an idea of why we have the decimal there. Now, with Mendeleev's original statement or organization, he found that this seemed like it was pretty normal. It seemed like it worked out pretty well. But as time went on, they were able to find a little bit more something different to organize it by, but it was still very close. Now, when we look at our periodic trends, we want to look at what happens within the group, again, vertically, and what happens in the period horizontally. So, when we look at atomic mass, we're going to talk about the group. It increases as it goes from top to bottom. And with the period, it increases as it goes left to right. Most times we'll look at it again from top to bottom, left to right. This is going to make it easier for us to sort of look at the properties and see what happens all in one direction. Now, as time went on, Henry Moseley and some other scientists looked at the information and said, well, it actually fits a little bit better if we try to organize it by atomic number. And so we actually went through a shuffling of the periodic table. It was only some slight changes that actually happened. Now, this is usually going to be found at the top of the box that you have the element, or where you find the element. And this is going to tell you the number of protons and electrons in an atom. This is going to be very, very important. So again, this is one of those things where you're going to want to put a little star just to say this is important. You need to come back and study this. Now, when we deal with what happens with atomic number in the periodic table, in the group, we're going to see that it increases as it goes from top to bottom. So from hydrogen, at the top, moving all the way down to francium, we have an increase in numbers. As we go from left to right within the period, we see that it also increases. So we're going to see that again, hydrogen over to helium, we had 1 and then we had 2, and so forth. Now, some other trends that we're going to look at, some of them might be, well, will definitely be brand new in terms of understanding what's there, but we're going to observe some similar properties and some things that look a little different. Now, the next one we're going to talk about is what we call ionization energy. This is the amount of energy needed to remove an electron from an atom. So if you imagine that the electron is like a new pair of shoes or a piece of food. There we go. I like to eat. So if I have a piece of chicken in my hand, I have to see how much energy will it take for someone, including my dog who's sitting here at my feet, to steal that piece of chicken away from me. This is going to usually be measured in joules. Of course, this would be a little bit difficult if I was looking at my dog, but I'd still have a little fight on my hands. Now, when we look at ionization energy, when we look across the periodic table, when we look at the group, it decreases as we go from the top to the bottom, meaning the numbers or the values get smaller and smaller and smaller as we go down within the group. And then it increases from left to right. Now, in my head, I'm trying to wonder, why would this happen? And this is all going to lead us into our discussion on atomic structure. As we look at how the electrons are arranged around the nucleus, we're going to start to see that, oh, well, these have a lot more electrons, and so it's actually easier to remove them from the atom because there's less pull from the nucleus. But again, we'll talk about that a little bit later. Now, the next trend that we're going to talk about is atomic radii. And I gave you this diagram here at the bottom for a very specific reason. When we look at an atom, It doesn't really have hard set boundaries like this diagram shows, but it does have an edge. So what we do to measure atomic radii is we say that it is 1/2 the distance between two nuclei. Between two nuclei. So as we see here at the bottom of our screen, if this is my nucleus right here, half the distance between those two is going to give me my radii, or my radius. This allows us to get a better idea of how the size is going to be. And as you see, it's measured in nanometers, so very, 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 very small. Now, with this in our groups, we're going to look at the fact that it increases as we go from top to bottom. The larger the overall atom, the larger the radius is going to be, which makes some sort of sense to us. Now, the other part is, as we look at the period, as we go left to right, it's actually going to decrease. And there are a couple of things that we're going to talk about a little bit later that is actually going to make that a little bit clearer. One being the shielding effect, or when we think of something being shielded or being blocked, how we can use that information. But again, keep that in line for when we get back in class. Now, our last trend that we're going to look at for this portion is electronegativity. Now, this is the ability to attract electrons when an atom's already in a compound. So if I have a compound made up of oxygen and hydrogen, H2O, it's going to allow me to predict how these two will actually interact with other things, because one will have a stronger pull on the electrons. Imagine in your head a tug of war. So if I'm here and this is my team, we're playing tug of war against another person who is much bigger than me. As they pull on the rope, most likely they're going to pull me with it. So, that being the case, the one that has the stronger electronegativity is also going to pull the electrons closer to it. But again, a discussion for a later time. Now, our trend within the group is that it's going to decrease as it goes from top to bottom. So the lower it gets, the less pull that it's going to have. Whereas within the period, as we go left to right, it's actually going to increase. So these are, again, some of the trends that we're actually going to look at, and we're going to dive a little bit more into as we go into class. Make sure you jot down your notes. Make sure you take the time and look at them and prepare yourself so you'll be ready when you get into class to participate in the activity. If you have any questions, please, please, please feel free to either leave a comment in the comment section or write them down. Please write them down so we can utilize them in class. The question you have may be the question that someone else is afraid to ask. Take your time, and this is where we're going to end it for tonight. Have a great one, and I will see you in class tomorrow.